Welcome back everyone, Patrick here, moving on to another question dealing with quadratic equations. So this is a popular kind of scenario. We have a pool that measures 12 meters by 10 meters and has a deck of uniform width put around it. And we have to find that uniform width in these three different scenarios. The deck's area is double the pool's area, or the entire area is double the pool's area, and then part C, the deck's area is 3/4 of the entire area. So it's basically like three different kinds of questions, and this kind of scenario can be presented in different ways, and that's why I wanted to show you a couple of different scenarios and how you can adjust when a question like this comes up. So let's start off with part A. Now, before actually getting into any of these parts, I want to create some general expressions for the pool area, the deck area, and then the entire area. So if we draw a diagram here, if this is the pool over here, so this is 12 meters by 10 meters, like that. And then we have a deck of uniform width put around it. Now, what does uniform width mean? It means that this width here is going to be the same as this width, and then this width right there. And that's what we're actually going to be solving for in each of these scenarios. So let's put a variable there. Let this be x, 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 and x, like that. Now, what I want to do is create different expressions for the pool area, and then the deck area, and then also the entire area. So let's start off with the most simple one, the pool area. Well, what's that going to be? It's just going to be 10 by 12, or 12 by 10, which is just going to be 120, and this is in meters, so it's going to be 120 meters squared. I'm just going to keep it as 120 for the algebra that we're about to do. So that's the pool area right there, 120. And that's going to be used especially in parts A and B, because in part A, we're told that the deck's area is double the pool's area. And then in part B, we're told that the entire area is double the pool's area. So it's just going to be doubling that amount right there. So that's the pool area. Now what I want to do is I want to get the area, an expression for the deck area, which is basically this border that's around. What's the area of that going to be? And I also want to get this entire area right here, the area of this entire rectangle here. And I'm actually going to start with the entire area, an expression for that, because if you think about it, if we have an expression for the entire area, then we automatically get an expression for the deck area, because it's just going to be the entire area minus the pool area. That's going to give us that deck area. So let's start off with the entire area. Now, what is this length going to be here? Well, if you think about it, this length is 12 meters, as we know. That's the pool right there. And then we're adding an x over here, and then we're also adding an x right there. So if you think about it, this entire length here is going to be 12 plus 2x, like that. We're adding an x here, and then we're also adding an x right there. 12 plus 2x. That's going to be the length of this entire area that has both the pool and the deck. And then what about the width of it? Well, we know that this here is 10, and then we're adding another x and adding another x. So we're adding 2 x's to 10. So the width of the entire area is going to be 10 plus 2x. So notice that we can get this entire area, an expression for it, by just taking the length times the width. So it's going to be 12 plus 2x times 10 plus 2x, right? Length times width right there. So that is the expression for the entire area. And we are going to be expanding it and whatnot, but I'm just going to leave it in that format right there. And now notice that we can get the expression for the deck area, because the deck area is just going to be equal to the entire area, as I mentioned, minus the pool area. right? This area of this deck around what I just drew in right there is going to be the entire area minus the pool area, and that remaining area is going to be the deck area. Well, we know that the entire area is this expression, 12 plus 2x times 10 plus 2x, and we know the pool area is 120, so we could just subtract 120 from that. And that right there would give us the expression for the deck area. So we have an expression for the entire area, the pool area, and then the deck area. And I recommend creating expressions like this on the side before even getting into the scenarios, because once you have these, you can just read the scenarios carefully and then adjust from there. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. So like in part A, what they're saying is that the deck area is double the pool area. So what you can do is first write it in words. So we can go, okay, if we take the deck area, right, that's going to equal double the pool's area. So it's going to be 2 times the pool area. Like that. So we took part A and created an equation for it, still in words, there's no variables here. I recommend writing it out in words first, the equation, just to make sense of it a little bit easier in your mind, right? The deck area is double the pool's area. And then what you could do is you could just take these expressions for the deck area and the pool area, plug it in here. So the deck area we know is 12 plus 2x, 10 plus 2x, minus 120, like that. That's the expression for the deck area, and that's going to equal 2 times the pool area, which is 120, like that. And now notice you have an expression to solve. So what we can do is expand all of this over here. So we would end up with 120 plus 24x plus 20x plus 4x squared minus the 120, that's over here, and then this is going to equal 240, like that. You can also do this expansion if you want right here and right here. So you don't have to, you could just take those expanded versions and then plug them into these word equations that you're going to create for parts A, B, and C, so you don't have to keep expanding for every question. You just expand it once. You could take that expanded version and then plug it into the equation that you're going to be using for that particular scenario. That would be the quicker way. If anything, we'll just remember what these expand to. Or you know what I'll do actually is I will take this, let's simplify it. So we'll have 4x squared plus 44x, like that, and then the 120s cancel out. So this here is the simplified or the expanded version of this. So I'm actually going to write this here. So we can use it for parts B and C, like that. Right? So that right there is the, if I take this and expand it, that's what the deck area is going to be as an expanded expression. Right? The 120s here canceled out. And then we got still the 240. Right, which has nothing to do with this expression for the deck area. Now we're going into the scenario. So I'll bring the 240 over. So that'll be what, minus 240, like that. And then notice we could take out a 4 from everything. So we'll have 11x minus 60, like that. And then a lot of times this won't factor smoothly. Sometimes you'll have to put in the quadratic formula, as you'll see in the future cases. But in this particular case, this actually does factor into x plus 15 and then x minus 4. So we get two solutions. X is equal to negative 15 or x is equal to 4. Now, negative 15 doesn't make sense because remember, what is x? X is that uniform width of the deck, and that can't be negative. And so we just end up with an x value of 4. So in part A, the answer for the width of the deck is just 4 meters, like that. Right? So that's how you do these kinds of questions. This is my suggestion of how to do it. Create these expressions on the side first, then create an equation with just the words, and then plug everything in, and then you just expand, bring it over to one side, and then solve the quadratic equation. Okay, so let's move on to part B, because we're told that the entire area is double the pool's area. So this equation would change because this here now, we would have this as entire area. The entire area is double the pool's area, like that. Okay, so now instead of plugging in this expression on this left side, we're going to plug in just those two brackets, and the difference between is just that minus 120 is not going to be there for the entire area, right? It's just that large length times that large width, that's the entire area, and that's going to be 2 times the pool area, which is 120, like that. Okay, so this entire area here, if we expand all of this, we would end up with 4x squared plus 44x plus that 120. Before we had that 120 subtracted, so those 120s canceled out. Now there's not going to be anything to subtract that 120, right? And then this 44x came from 20x plus 24x like we had before when we expanded it. Okay, so this here is the expression, the expanded expression for the entire area. So what I'm actually going to do is I'm going to take this, I'm going to keep track of it, just because I feel like in part C it's going to be easier to use this expanded expression versus using these factored expressions. Again, you don't have to do this, but it does save time because you're only doing this expansion once, and then you could take the expanded form and then plug it into these equations, right? So that's the entire area expanded, and then we got 240 over here. Bring the 240 over, so we end up with 4x squared plus 44x. 120 minus 240 would give us negative 120, like that. And we end up with another quadratic equation. And we could take out a 4. We got x squared plus 11x. And then 120 divided by 4 would give us 30. But in this particular case, this can't factor. There's no two numbers that multiply to negative 30 and then add up to 11. And so what we would have to do is take these parameters, put it in the quadratic formula to solve, right? We're going to have decimal values in this case. And so the b is 11, so we'll have negative 11 plus or minus. You could also put it in the quadratic formula from here. So you could use the a value 4, b value 44, and then the c value negative 120. I took out a 4, so I'm going to be plugging in 1, 11, and negative 30 for the a, b, and c respectively. But you could also use the quadratic formula from there. You'll get the same solutions. So then we'll have b squared, which is 11 squared minus 4 times the a value of 1 times the c value of negative 30. And that's going to be all over 2 times that a value of 1. So I took this quadratic in the brackets, plugged it into the quadratic formula. And when you do all of that simplification, you'd end up with negative 11 plus or minus root 241 all over 2. So there's actually going to be two solutions, 2.26 and then negative 13.26. But according to our word problem, we can't get a negative value, right? Because x represents that width of the deck. And so the answer in this case is 2.26 meters. That's what the width of the deck is going to be in this particular case, where the entire area, which is the pool and the deck, is just double the pool's area, like that, right? So the solution for part B is 2.26. Now in part C, what they say is that the deck's area is 3/4 of the entire area. So let's first put those into an equation that just has words before even plugging in any expressions. So the deck area is 3/4 of the entire area. So if we take the entire area, multiply it by 3/4, or 75% of the entire area, that's going to be the deck area. Another way to think about it is that 25% of the entire area is going to be the pool area. That's actually another way, now that I think about it, to set up this, this equation. It might be easier because we actually then, because this is going to be an expression and the pool area is going to be in terms of numbers, so we can go 1/4 of the entire area is actually just going to be the pool area, right? Because the entire area is the pool area plus the deck area. So if the deck area is taking up 75%, then the pool is taking up 25%, right? And then the pool area, that's just 120. This is going to be 1/4. And then we could plug in that expression for the entire area right there, this 4x squared plus 44x plus 120. You could also plug in that factored form, but you're going to have to expand, and we already did that, so I'm just going to plug in that expanded form there. So this, I'm not going to go about it this way, but it just came to my mind now. This is actually an easier way to solve it because we're not going to be dealing with variables on this left side. You're going to see the way we solve it. We're going to still have these variables, right? On the left side, in this particular case, you're not going to have that. You just have this 120 to work with. So you could distribute this 1/4 in the bracket, bring the 120 over, and then just simplify and solve everything. Okay, and you would get the same solution. That x value you solve for, if you do it this way, should be the same x value that we're going to get when we do it that way. Okay, but this is not always the most intuitive thing to think about, right? With the words that we're given, it's intuitive to make this equation, okay? And it's going to be a tougher equation to solve than this one, so that's the trade-off. This equation is easier to solve because we only have a 120 here, but it's less intuitive to come up with this, versus that equation is easier to come up with, but the algebra is going to take a little bit longer. Okay, not a lot longer, but a little bit longer, but you should get the same solutions if you do it this way. So just another perspective that I thought I would mention for this question. Okay, so now let's plug everything in. So the deck area, again, we have that expanded. It's just 4x squared plus 44x. And then we got 3/4 over here. And then we have the entire area, which is that expanded version. Like that. What's nice is 3/4 if we multiply it by all these, or 0.75 if we multiply by all of these, we're going to get smooth integers. That's not always going to happen. But in this case, it's nice that it does. So we'd end up with 3x squared. 3/4 of 44 would be 33x. And then 3/4 of 120 would be 90. Like that. And then because we have a 4 here and then a 3 here, I'm going to bring all of the right side over to the left side to keep that leading coefficient positive. Bring this over. 4x squared minus 3x would give us x squared. Bring the 33 over. 44 minus 33 would give us 11x. And then we got minus 90, and then that's going to equal 0, like that. So now we have this quadratic equation to solve. And in this particular case, there's no factoring, smooth factoring. There's no two numbers that multiply to -90, or no two integers that multiply to -90 add up to 11. So we actually have to throw this into the quadratic formula again in order to get these solutions. So we'll have -11 plus or minus 11 squared minus 4 times the a value of 1 times the c value of -90. That's going to be all over 2 times that a value of 1. And that is going to simplify to this. So we're going to have two solutions because of this plus or minus. We're going to have 5.47 meters and then -16.47 meters. the negative, as we've mentioned in parts A and B, we would ignore that. And so the answer to part C is 5.47 meters. Okay, that's going to be the width of the deck, right? So again, the steps for questions like this, I recommend making 3 expressions for the pool area, entire area, deck area, and then based on whatever the scenario gives you, creating an equation just in words, and then you could take those expressions, just plug it in, and then solve the equation. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.